Hey there, Gregory Carlson here with the Calculus Building. We've learned how to take derivatives of functions that are adding and subtracting, and we learned the power rule, and so we can now take derivatives of polynomials. So that's really nice. So the question then is, we've reached the next level. What would be the derivative of this? If I took the derivative of two functions that were being multiplied together, what would be the derivative of that? And unfortunately, it's not as easy as just taking both of their derivatives and multiplying them together. So let me show you. This is what the answer is. According to the product rule, if you're taking the derivative of two functions that are multiplying, you take the derivative of the first function and multiply it by the second. Okay? And then you add it to the derivative of the second function times the first function. And so that's it. So if you take the derivative of two functions multiplying together, you take the derivative of the first one, multiply it by the second, and then take the derivative of the second and multiply it by the first, and then just add them together. So if it helps, you can think of it as the derivative is equal to f prime g plus f g prime. Just like that. So let's prove this. The proof is a little tricky, and then in the next section we'll do some examples. So we want to say that the derivative of this is equal to, and as you know, we're doing a proof involving the derivative, so we're going to have to use the definition of the derivative. So we got the limit as h is going to 0 of, up here I'll have f of x plus h times g of x plus h, right? Because I'm taking the derivative of all of this, so it would be f of x plus h, g of x plus h. Now I'm going to leave a giant gap right here, and you'll see why in a second. And then we subtract f of x, g of x. Okay, so far so good. I've got my limit. And this is all over h. So that's the definition of the derivative of this. And you might be wondering why I have this gap right here. And the reason is because I'm going to do something tricky. I'm going to subtract f of x plus h, g of x. Okay? And now I've subtracted f of x plus h, g of x. So in order to keep this right, I now need to add it. Okay? So at first, I haven't changed the fraction because negative of this plus this, they would just cancel each other and become a 0. So you might say, why, Mr. Carlson, did you do that? Why did you add those two things? And the reason is because this is going to help us simplify. So let me show you. We have the limit as h goes to 0. I'm going to factor out the f of x plus h from both of these. And so this will be times g of x plus h minus g of x all over h. Okay? And now I'm going to break up this 2. So I'm going to use this plus to break the fraction into 2. So I have another limit as h goes to 0. And over here, I'm going to factor out the g of x. Okay? So this is going to be g of x. And then we have f of x plus h minus f of x all over h. So you can see what we just did right there. You can see how I've kind of broken it up into two limits. And basically what's going to happen is we can take this limit and apply to these things separately. Okay? So I can take the limit as h goes to 0 of f of x plus h times the limit as h goes to 0 of g of x plus h minus g of x all over h. So again, you can do that. You can break that up into those two limits, plus the limit as h goes to 0 of g of x times the limit as h goes to 0 of f of x plus h minus f of x all over h. Okay, so you can see what I did there. I kind of broke this up into these two limits, and I broke this up into these two limits. And you might notice that right here, I have the definition of the derivative of g, and right here, I have the definition of the derivative of f. And so what is the limit as h goes to 0 of f of x plus h? Well, h goes to 0, so that's going to be just f of x times the derivative of g plus, what's the derivative of h goes to 0 of g of x? Well, there's not any h's in here that we can see because it's just g of x, so it's kind of like a constant number. It's like the number 10 or something. And so that's just going to be g of x times, and you can see here the definition of the derivative of f. And so there you go. That's how you can demonstrate and prove the product rule. And I wrote it it's easier for me to remember it this way, so I wrote it kind of backwards. So you could rewrite it like this if you wanted. F prime of x, g of x, plus f of x, g prime of x. Or f prime g plus fg prime. And again, I just do that because it's easier for me to remember. QED, so we just proved the product rule, and I hope it made sense. This step was a little bit tricky, so if you didn't think of that on your own, that's okay. But hopefully this proof makes sense to you, and in the next video we will do some applications of the product rule. The example problems are a lot easier than the proof. So I will see you in the next video.